Hi, I'm Narender Kumar. I'm a senior architect with 12 years of experience. I'm a certified Databricks Architect Champion as well. In this video, we are going to build an end-to-end modern data engineering project that you can directly add to your resume and explain in any of the interviews. And this project we will create with all the free resources. And I have included all the data, code, and other artifacts that I'm going to use so that you can also build it step by step on your own. In this video, we will start by understanding the use case. Then we will jump to the architecture. And after that, we will set up the real data sources in Salesforce and Postgres DB with the trial accounts so that you can understand how the real sources work in real projects. Then we will ingest the data from those sources as SCD type 1 and type 2 using Lakeflow Connect. Then we will transform the data using Spark declarative pipelines and build the silver layer and gold layer. Gold layer will be the standard star schema. Then we will build a semantic layer using Databricks metric views. After that, we will consume the data using a dashboard and a Genie space where user can ask anything in natural language. And at the end, we will orchestrate everything end to end using a Databricks job. Along the way, we will use Databricks Genie code to improve the productivity and create many of the artifacts using AI automatically so that we can save a lot of time during the development process. And before we get started, if you are new to my channel, so I have created another finance domain project as well. And I have created videos like CI/CD process, PI data handling, and I have also created complete playlist about PySpark and all the Databricks features. So feel free to check them out. Let's start by understanding the business use case so that we know what we are building, why we are building, and how we are going to build it. So the background of our business is that we are running a retail business which generates large volume of CRM, inventory, and transaction related data. This data it is currently spread across multiple systems and file formats. And business they need a quick insight into different data which is coming from various sources. So that is the background. And the current problem which business is trying to solve is that current data it is spread across multiple disconnected sources, and the traditional pipelines they make it difficult. They are slow and they are not scalable to perform huge amount of data. And currently the business users they lack sales service analytics. They don't have a combined data so that they can get overview of various KPIs. And the solution approach that we have taken here is that we have built a retail analytics platform on Databricks using medallion architecture like bronze, silver, and gold, so that it is scalable and it follows all the standard scalable data platforms. And we have integrated Salesforce, Postgres SQL, and cloud storage data into our platform as sources. And to serve the business users, we have created retail dashboards and Databricks Genie so that they can see the reports in the dashboard and they can interact with the data using natural language using Genie workspaces. So that will be our final solution. So now as we understand the use case, now let's jump to the architecture and let's understand technically how we are going to build it. So first of all, we will use three data sources, Postgres, Salesforce, and Blob Storage, which we will be setting up ourselves as free version of them. And then we are going to ingest the data using Lakeflow Connect and Autoloader. After that, we are going to transform the data to build the standard medallion architecture as bronze, silver, and gold. And this we will build using the latest Lakeflow Spark declarative pipelines. On top of this transformation layer, we are going to build a semantic layer, which is the latest concepts lot of clients are exploring and even using it now. And finally, we are going to consume the data in terms of dashboard and Genie workspaces. And while we build this solution, we are going to orchestrate it to run on a daily basis using Databricks Jobs. And for the governance, we will use Unity Catalog, which provide all the governance capabilities across entire process. And whatever pipelines, notebooks, code, dashboard we will be building, we will be using agentic AI based development. So Databricks, they have recently released Databricks Genie code, which is now getting very popular because it can do so many things automatically. We have to do less and less manual coding now. So we will try to use it across our development process and understand how it can improve our productivity. So this is all about the architecture. Now understanding the tables that we are going to use. So on the source side, we will be ingesting account and opportunity tables from Salesforce, product catalog and inventory related tables from Postgres, and transactions related file as a table from the cloud storage. So these we will be ingesting, and in our final gold layer, we will be building the star schema. So we will have our central fact sales table, which will be surrounded by the three dimensions. So this will be our final gold star schema architecture. So this is all about the theoretical part. Now let's jump to the demo. Let's build everything with hands-on from scratch. To ingest the data, the first thing we need is a data source. So first of all, we are going to set up a Postgres SQL source. And I found that this Neon Postgres is really user friendly and very easy to set up. This also provide a free access tier which we can use. So if we simply search Neon Postgres, it will come up as the first link. If we go there, we are going to sign up first. And for signing up, you get these various options. We can use any option, but we will use the easiest one, which is login using Google. So here we can use any Google account that we have. So I'm going to use this one for this demo. Now it is asking for our permission, so we will allow it. After that, it is asking for a organization name. So we can give here any name. We can leave our name as well. And this is just for their audit purpose, what we are using it for. We can put any detail here we want. Here in the project name, let me give it as a retail project. So it is this will be our project. We can give any name here. Region, we shall select whatever region is closest to our location so that it will run faster. I live in India, so Singapore seems to be the closest one. And then we are going to click on create project. After creating the project, it has provided this connection string. So this is going to be very important because this is what we will use to make a connection in Databricks. So let me copy this and paste to a notepad so that I can use it later on. Now I will go back and simply go to the project. So with this, our project, it is ready. Our database initial version, it is ready. Now what we need to do is we need to create our tables. So by default, it comes with this Neon DB database. This is fine for us. So simply here we will create our tables first. And to create the tables, I have included these SQL scripts so that directly we can simply run them. So first of all, it will drop the table if it is there. Then it will create the table. Then this is the data it will insert into the table. And it will also insert some invalid or not good quality data so that later on it will be helpful when we will apply data quality checks. So I will simply copy this script and then paste to our SQL editor and simply run it. So it has created our table, inserted 20 records, then inserted 3 records. So now our table shall be ready. Let's give it a try. So simply if we do select star from our table, so we can see the data, it has been loaded. So now one of our source table, it is ready. Let's create another one. And for the second one, again, we have a SQL query that we are going to run. Its structure is same. First, it will create the table, insert good data, insert some bad data. So I will simply copy it and go to our SQL editor and run it. And now our table is ready. Let's confirm whether the data has been loaded properly. So select star from, this is our table. So now our table is ready. So with this, now two tables are there. We can see directly here also in the table section. So these two tables are ready, and this is what we will use as the actual source of data in Databricks. So now let's go to Databricks and let's understand how we can ingest this data. So now I'm in my Databricks workspace and we will start with the ingestion part. So to ingest the data, we are going to use Lakeflow Connect. So that we can find in jobs and pipelines. Then we go to ingestion pipeline. This ingestion pipeline, it is nothing but they call it as Lakeflow Connect in terms of Databricks documentation. So if I go inside, we see that all these sources are currently supported. Databricks, it is working a lot to add more and more sources, but currently also the list is huge. So we are going to connect with Postgres SQL. So currently this is in preview. It means they are still doing enhancements to this. After some time it will be very stable, but we can use it already. So after we click this, the first step it is creating a connection. So now we need to set up a connection with our Postgres that we have set up. And if we click on create connection, so here we need to give a name to this one. So in the connection name, basically we can give it anything. It is just a name, but we will mention like it is our neon Postgres, and then let's say project. So next we need to provide the user password and host. This is how actually it will connect with our Postgres. For that one, what we need is this string that we had copied while creating the Postgres. This is exactly what we will need. But if we see this, we are not able to understand which one is user password and host name. So this is where we can take help from ChatGPT or any LLM. So let's open it and let's ask it like, based on this URL, give me the username, password, and host name. But before I enter this, I want to call out that this is not recommended for production projects because there this contains the real username and password. Here we are using for learning purpose and we are going to delete it later on. So it is okay. But after understanding which one is username and password, we can always refer it. And if we are trying for real project, we can replace these things with something dummy and then use it. For now, I will go ahead. So this will understand it and give us the username, password, and everything. So we can see this is the username that we have. So let's use this. So this is our user. Now this is the password which was there. So let me paste in the password section. And then this is our host name. And here we can see the database we don't need to provide. And then there is a port number which is default. This database, let's copy it. We will see if it is required later on. So now I'm going to click on create connection. So with this, our connection, it is created now. And now I will click on next. Here I need to provide a name to the pipeline. What we are going to do here. So we will mention here that this pipeline name, it is Postgres to bronze, because here we are ingesting the data from Postgres source to bronze layer. So that is the name we will provide here. And here we need to provide a catalog and schema. So for that, let me duplicate this tab. We will create a new catalog there. So here if I click on catalog, we can click this plus icon and create a catalog. So for this project, we are going to use the catalog named retail underscore Q. So retail Q, it is the virtual name of our company. So we will use it. Simply we will create it. And let's click on view catalog. So now our catalog is created. By default, there are two schemas. So here if we go back and let's see if that is coming. Yes, it is coming here. And here we are going to create a new schema. So this is Postgres bronze layer. So the name of the schema also we will give it as Postgres branch, so that that is where our tables, any log files, DQ checks, everything will be created and stored there. So now let me create it. Uh, Now our catalog is ready. So let's click on create pipeline and continue. So now it is trying to connect with our source and trying to analyze what databases and tables are there. So here, instead of providing the list of databases, it is asking the name of the database. And if we see here, so this is the name of the database which was there for us. So I will provide it. Click on this plus icon. And within this database, we can see these are the schemas. And if I expand the public schema here, this is where we can see both our tables which are there. And for these tables, it is asking for a cursor column. So using this column, it will be able to identify the incremental data. So that is why providing this column, it is very important. So now it has fetched the list of columns from the table. So here there is a column updated date. So this is the column we are going to use. And if by any chance we don't have any incremental column, we want to do a full load every time. So we can simply click this one so that every time it will do a full load. In our case, we have this column. So this is what we will use. And if I scroll here below, so this is where we are getting an option history tracking. So if we make it on, then it will make the target table as SCD type 2, which is slowly changing dimension type 2. Don't worry if you are not familiar with this terminology. I will explain when we see the target table how the data is going to change. So for one table, we will enable it. And for the other table, we will keep it disabled so that we can see the difference, how SCD type 1 and type 2, what exactly it means and how exactly it works in Databricks. So for this table also, we are going to select a cursor column. And out of these columns, this is the column which will be our incremental column. So after selecting the table, their configurations, we are going to click next. So now this is our destination section, and this is where our target table will go. And we want them to create in our retail queue catalog and then Postgres bronze schema only, which is selected by default. So simply we will click next. And the next section, it is about scheduling and notification. So by default, it is saying that it can run it every hour, but we don't want it. So we will delete it. And here is the notification part. It is saying like in case of failure of this pipeline, it will send us an email. So we will keep it so that we are notified automatically. Now I'm going to save and run pipeline. So once I click it, it has saved the pipeline. Now it will start the ingestion process. It has multiple steps. Currently, we can see that it is trying to initialize some resources. Once it has the available resources, it is trying to set up the tables. And after that is done, now it know what tables it is going to work. So it has created this lineage. So this is our source tables that it is reading. And these are the target streaming table that it is trying to create, where it will load the data. So here also we can see the same. So currently both of them are in progress, and it is trying to ingest our data now. And now the ingestion it is complete, and we can see that this is the time it took, and these are the number of records it has inserted into the target table, which is same as our source table. If we want to check out these tables, we can simply click on this icon. It will open a new tab and show us our table. So here is our inventory table. And if we want to check out the sample data, we can go here. We need to select the compute, and then it will show us the sample data. So here we can see our sample data, and we can see our table has been created successfully. And if we go to the other table, let's check out whether there also the data is coming properly. So here also we can see the data, it has been loaded successfully and properly. And here there is one difference between both the tables, which is related to the history tracking or the SCD type 1 and 2. So for this table, because we had enabled history tracking, So this has automatically added two columns here, start 8 and end 8. So end 8 column, it is by default null, and start 8, it has put up like same value as updated 8, because that is when the record has been started or it was available. After any record is updated, for example, if for this particular product, which is this pavilion laptop, if we change its category, subcategory, or name, whatever we want to change, or let's say its price has been changed, then after changing of the price, what will happen is when we run our ingestion again, it will not update this same row, but in this row it will mention the end 8 time is some time, so that is when the record's validity has been ended, and then it will create a new row where this end 8 will be null and start 8 time will be there. That way it is able to tell us that this is when the validity of this record started, this is when it is ending, and then there can be another record with same product ID. So when the entries like that are maintained, we are able to track the entire history from what time to what time, what were the values. After changing from this time to this time, these were the values. So that is how we are able to track the history, and that is why it is called as SCD type 2, which is slowly changing dimension type 2. And if we go to our inventory table where we had not enabled the history tracking, here we will notice that there is no additional start 8 and end 8 columns. So in this case, whenever anything is updated, let's say whenever the quantity is updated on the source side, then it will update the same row. It will not insert a new row, or it will not track the history. So that is why it is called as SCD type 1, where the target table, it is snapshot of the source table without any track of history. So now that we understand this conceptually, let's try out with one example by modifying some data in the source so that it is clearly understood via the demo as well. So now I'm back into my source, and here let's say if I make any change, let's say this quantity here from 24 we are changing to 25, and then this timestamp column, it will be always updated. So let's say I want to change it to now, the current time, and this is for this inventory ID 40. So we have made this one change, and now let's make one change into our product catalog table as well. So for this ID P0020, let's change its units price. Let's say its price has been increased now. So let's say now it is 10,000. Okay, and the timestamp also we need to update here. So let's change it to current timestamp. So you will see it is very user friendly to make any changes. So that's why also I chose this neon. So now we have made our changes into our source. So now let's go back to our pipeline and let's start the pipeline again. So now it will be able to automatically identify what are the changed records, whether history tracking was on or off, and then the target table it will automatically maintain as SCD type 1 or 2. So now the execution of the pipeline is completed. And here we can see that for the table where the history tracking was off, it has updated one record. And when the history tracking was on, even though we updated one record in the source, it has updated two records or upserted two records in the target. So let's check out the difference there. First, let's see in our inventory table. Let me refresh this tab so that it will show the newer data. So now if we go below, we notice that quantity has not been updated to 25, which is surprising. But the timestamp here, it has been updated automatically. So probably I may have made some mistake. Let's check out in our actual source whether we really changed it or change was saved. Yeah, so here if we see, right, so it was not properly saved. That is why it is not reflecting. So let's change it again to 25. This time it is saved, and let's change the time also again to current time. So then we will run our pipeline again to confirm this change. So now simply we will start our pipeline one more time. And while it is running, let's check out our other table where we had made the change, and let's see the data how it is coming there. So here if I scroll below, here we had made the change for the ID 20, I think. Oh, here it is showing it at the top instead of bottom. This can show randomly anywhere, no big deal. So here we can see that we had changed the value from this 9999 to 10,000. So it is maintaining both the records here. And if we go to these values, start date and end date, so the older value which was there, so it has updated the end date column, and then the newer record which is there, it has updated the start 8 with that time and end is null. So what it means is that this record, it has expired now and it contains the old values, but still we can see this value as a historical value. And wherever end 8 is null, so that means this is the newer and latest value. So that is how this table is maintained as SCD type 2. Now let's go back and see if our pipeline is completed. So yes, now it is completed. It has updated one record again. So if we go to our catalog and go to inventory table, hopefully this time it would be updated. Yes, now we can see that the quantity, it has been updated to 25. But here as expected, it has not added any additional entry. It has updated the exact same row here. So this is how SCD type 1 works here. And with this example, now you will notice the power of Lakeflow Connect. So far we have not written any single line of code. We simply performed some very easy operations through the UI. We simply selected our table, selected the watermark columns, and that's it. So just selecting the target and destination, it worked for us. And we are able to do SCD type 1, type 2, a very easy and very simple way. So that is the power of Lakeflow Connect, that without writing any code, we can ingest the data, we can control how we are going to ingest the data. That is why it is becoming very popular, and newer projects are in lot of projects, lot of clients, they have already started using this. And now that we have worked with Postgres, next we are going to work with Salesforce source, and that is also really interesting source, and I have put up really good effort to explain that in detail. So please don't skip it. Follow all these processes so that you will get understanding how the Salesforce works, how what is the difference between Postgres and Salesforce, and how the data ingestion process, it can be different or same. So Salesforce, it is little bit tricky than this one, but again I have tried to make it very simple. So let's go ahead and set up our Salesforce account and ingest some data from there. So for that one, I will open a new tab and I will search for Salesforce trial version. Now we will click on this 30-day free trial, and then this is the sign up page. So we need to provide our first name, last name, any job title, any company name, any email ID which previously we have not used with Salesforce, and then a phone number. After that, we agree to these terms and conditions, and then we need to click on this start my free trial. After that, it will say that it has sent an email where we need to activate our account. So let's go ahead and check out our email. If I check out my email, so this is the email that I have received. It is asking me to verify my account, and then it has given a URL and username. So this username, we will need it later on. And this first, let me verify my account. So first of all, it is asking to reset a password. So I will click on reset password. And here it is asking to provide a new password. So here we can provide any password that we want. Just remember it, whatever we are providing. And then it is asking for a security question. Here also we can provide any value and then click on change password. After that, this is kind of a survey they are doing. So we can select any values here, whatever we want, it doesn't matter. And then automatically it will take us to the login page. Sorry, not login, the landing page. So this is how the home page of Salesforce looks like. And by any chance, if it is not taking you to this landing page, then what you need to do is you need to click on this URL here and then provide the username and password. So the username will be this one. Remember that we don't have to use our email ID, but we have to use this username everywhere. And password will be the password that we had provided while resetting the password. So once we are ready with the Salesforce setup, so now we need to import some data here. So on Salesforce side, we are going to use two tables. One of them will be accounts. And in accounts, simply we are going to import some data. So I will click on import. I will click on import from file. Click on next. And this is where we will upload our CSV file. So I have already prepared a CSV file with the right data. So this is the folder that I have uploaded, and this is the file we are going to upload there, Salesforce Accounts history.csv. So let me drag this CSV over there. Now let me click next. Now it will try to map the fields in the CSV file with the data which is standard data in terms of Salesforce. So it is ready to start the import. We will continue the import. And now it is doing the import of our data. And here we can see the progress. It is done. So here if I refresh this using this button, we will be able to see the accounts has been populated. And this is the dummy data. So don't try to use any of the phone number or actual information. This is I generated from LLM. And with this, one of our table, it is ready. And just to explain about this Salesforce source, so what happens is, right, so the real people who use this, they can bring historical data like this, but whenever they want to make a connection with new customer, they get a new customer. So normally from here they enter the information and then they save it. And within this Salesforce software, they can maintain accounts, sales, services, marketing, all this information they can maintain, which is interlinked. So it becomes very easy to maintain all this data, track where each and every order is. And there are so many different features of this Salesforce. That is why it is very widely used in retail and other sales and any other data management services. And with one of our data set ready, the second data set we are going to use is opportunity. So we click on this sale. The sale, it can have different type of data. We are going to use this opportunity. Opportunity, it means like a order in Salesforce. So here also we will follow the same process. We will click on import, click on select from file, and then we have this other file opportunities. So this is the file I am going to upload here. And now the mapping, it is coming out properly. So let me start this import. It is in progress. Here we see it. If I expand it, we can see it is completed quickly. So now our opportunities shall be ready. And with this, the opportunities data has been populated. Now these opportunities are like orders, and each of the order that has any account name with it, so that it know from which account this order has been placed. So there is no direct way to direct use it while importing, because here we need to provide the account name which is there, the actual account which is there. That is how the link works in Salesforce. So what we will do is, instead of mapping each and every account manually, first let's check out the name of any account. Let's say something starting with the uh, elite. So we will what we will do is we will click on this select all button here and edit it, search for elite here, and there are different accounts coming in. So we will select randomly anyone, and if I click this, it will apply this account for each and every opportunity. And if I scroll below, looks like the first 50 opportunities were selected. And if I scroll below, we can see in total there are 100. So now all 100 are selected. So let me edit it again. And if I simply select it, now it will update it for all the 100. So it has been updated. So by default, everything will be linked to the same account. So instead of linking that way, let's change it for some of them. Some of them, let's use any other account which is there. So instead of this account, we need to provide another account. For that, let me duplicate this tab so that we can see what other accounts are there. And apart from this elite keyword, a fresh keyword is there, global accounts are there. So let's try fresh this time. So this one we will select, and for these items it has been selected as fresh. And let's give it one more so that the data looks like properly mapped or something. For these, let's change it to something global. So now the opportunities, they belong to three different accounts. So now I'm going to save it. And with this, our source data, it is ready. Now let's go to Databricks and let's see how we can ingest this data and how it is different from working with the Postgres. Now I'm back in my Databricks workspace. So let's go to this jobs and pipelines. Let's create another ingestion pipeline here. And this time we are going to select Salesforce. And here the first step will be making a connection. So I will click on create connection. Here we need to give any name. So let's say it is Salesforce retail test. And then I will click on this authenticate and create connection. Now it will ask us to log in and it will ask for a username and password. And there, by now, you know that this will be the username we have to use. We don't have to use our email. So let's remember that. It has opened a new window. So this will be the username. Here we need to type the password which we had used while creating the account and click on login. I will remember this. I will save it. It is giving some kind of warning, but we are good because we know we are going to make this connection. So I will allow it. And now the connection, it is ready. So that is how easily we can set up that connection. And the good thing here is that we didn't need to provide any URL from our side. Based on the username we had provided, it was able to automatically detect which URL this username belongs and then use that URL here. So that is how making this connection, it is pretty simple. Now let's click on next. Here we need to provide a name to the pipeline. So this time it will be Salesforce to bronze because we will be loading these two tables into bronze layer. And here we will use the same catalog that was there. And schema, we will create another one with the same name like Salesforce, then bronze. So let me create this. Now let's click on create pipeline. And our pipeline, it is created. Now it is connecting with compute and trying to understand what all source tables are there which are available for ingestion. And here you will notice that so many tables are coming, even though we inserted the data into two of the tables, but all these tables are coming. And the reason for that is Salesforce, it has a very standard set of tables. Whatever we do, any operation through UI at the backend, it automatically create all these table structures. By default, these are blank. They don't have any data, but the table structure, it is there, which is very standard across Salesforce. So the one difference between Postgres and here is that here we don't need to create any table. We just need to import the data or use the data into the ready to use options. And the underlying tables, those has very standard schema, very standard connection between the tables. And those are in structured, those are structured in the same way for all the customers. That is how Salesforce works. So the table we created, one was account. And in this table, we are going to enable the history tracking so that we can see how the SCD type 2 works. And here one other difference we will notice is that it is not asking for any incremental column here, the cursor column which it was asking. And the reason for that is in Salesforce, again, there is a very standard way how it can track the things in automatically internally. So we don't need to specify anything, but Salesforce knows this is the column which will be updated whenever a record will be inserted or updated. Databricks also know this is the standard column. So we don't need to select or configure anything. That is the understood information which is taken care at the backend. That is how this connection works. And the other table we had created was opportunity. That is where we had inserted some data. So let's select this one. And for this one, we will keep history tracking as off. And we will notice there is this other option also where we get the list of columns which we can ingest. And here we will see that the column ID is deleted. These are very standard. We cannot unselect or change them. These must be ingested. And the incremental column I was talking about, that is this one, system mode timestamp. So this is automatically selected. So we don't need to provide in the previous screen. All other columns are optional. We can untick them if we don't want to ingest them. But for now, we will keep all the columns. And here is a option that it says include future columns. So in future also, if there is new column added on the Salesforce side, so that will also be added automatically into the target. So these are the default settings we will live with. Now I will click on next. And here we need to select where our target data will be going. This is the destination section. So this is the right location. We had created this schema. So this is where we will load our data. Now let me save and continue. Now we are at our final step. And schedule wise, it is saying it want to run it every 6 hours, but I don't want it. So I will go ahead and delete this. And failure notification, I will leave it as it is. Now I will click on save and run pipeline. So it will create our pipeline and then it will run it automatically. So here it will be the same process. So the pipeline, it is getting started now. Let's wait for it to be completed. Now the pipeline has been run successfully, and we can see for account it has inserted 50 records, and for opportunity it has inserted 100 records. Now let's go ahead and check out our tables first. So I will click on this icon. It will open the table it has created. So the table it is created successfully. Now let's check out some sample data. For that we need to start this compute. And here we can see the sample data. So these are the kind of IDs which are generated automatically in Salesforce. And we can see the data it is coming properly. You will also notice that there are a lot of null columns because these are very standard fields in Salesforce. And everything I had not put in the CSV. So some of the columns I had put up so that we can understand its functionality. And then we will also notice that this table, because we had enabled the history tracking, it has added the start date and end date column. So this is exactly same as what worked in the Postgres. So same way it will also behave. We will test it as well. And if we go to the opportunity table, here also let's check out some sample data. So here we can see it contains order related data like order name, description, what stage the order is, like that it is containing. And here also the data has been loaded properly. And because here the history tracking was off, so there are no additional columns available here. Now let's understand if we update something on Salesforce, how does it behave? So now I am back in my Salesforce. So here let's say for this first ID, it is already closed. So second one, it says qualification. So this one we are going to change its stage. Instead of qualification, we will say that it is closed won. So it is a won deal for us, and I am going to save it. So this is one change we have done, and here we don't need to make any change to the modified or the timestamp column because that is maintained automatically at the backend. And here I want to call out like if I click this drop down, we get the different options here. So sometimes if you are you check out this tab after some time, so you may see this recently viewed. and sometimes it can be blank also. So if you see a blank screen, you can go here, click on all opportunities so that you see every data set which is available. Now let's go to account and make some modification there. So for this first account, let's modify the phone number here. So instead of this actual phone number, let's put something like 9876 so that it is easy to remember. So I'm putting this number here and I'm going to save it. So now we have made some modification in the source for both of our tables. So now let's understand how we can ingest these changes. So simply I am back to my pipeline, the same pipeline. I will start it again. After some time, the execution it is complete. Both are successful. So let's check out our data now. So now we are in our account table. Let me refresh it so that the new data is available. And here we will notice that the IDs are different here, not 1, 2, 3, because internally Salesforce stores these IDs. So to know the which record was updated, let's go to Salesforce first. And here we will notice the with the account name Elite39, that is where we had updated the phone number. So if we go back, we search for that account here. So this one 39. So these are the two rows which it has created. Earlier it was the one row, and as expected, because history tracking was on, it is keeping this table as SCD type 2, and that is why the previous entry it has marked as end 8. It has put the timestamp, and for the new entry it is keeping this as null. So it has made two entries. And if you want to see the update which was there in the phone number, so here we can see for newer entry this is the phone number we updated, and for older entry the old phone number is still there. So this was for the account table. Now let's check out the opportunity table. And for that also we will have to see the name of the opportunity which we had updated. So if we go to opportunity tab here, we had updated the second one, but this one doesn't seem to be closed one. So yes, the thing I was talking about, right? So sometimes it shows the recently viewed automatically. So if we select all opportunities, then it will show the original order. So the second one we had updated. So wherever it was like elite accessories order 2, previously there was some other stage and we changed it to closed one. So let's check for this elite accessories order 2. So let me go to the sample data. And here let me find that entry. So if I search using the same keyword, so this one is 28 note 2. So here looks like this control find is not working. Let me sort it based on the name, then it will be easily available. So yes, this is the entry, elite accessories order 2. So if we see its stage name, it is closed 1. And we also notice that this last stage change date, this also has been updated so that we know like this is when we had made the change in the source. So these kind of things are automatic in Salesforce. So now we are able to confirm that we have ingested the data from Salesforce. We have made some changes and those changes also are reflecting properly as SCD type 1 and SCD type 2 both. So with this, the Salesforce ingestion process also it is complete for us. And now we will work on our third and final source, which is going to be Blob Storage. So in practical, the Blob Storage or S3 bucket or like GCP cloud storage, these are the cloud storage where the data can come as files, which can be any files in any format. It can come from any of the source. And how do we connect those sources with our Databricks is that we create a volume. And that is what we will do here so that we can replicate the same behavior of any storage account. So this is our catalog. We are back here. Here we will create a new schema. So normally in real projects, we create a separate schema to maintain our volumes. Volumes, these are like file storage, which are there, which we can link to any external storage. So here this is not the real volume. It is just a catalog with the name volumes we are creating. Inside this inside this schema, we are going to create our volume. So now our schema it is created, and here we get a option to create a volume. So here the name of the volume, it can be, let's say, blob source. That is the source we are going to use. And when we have a real cloud storage account, then what we do is we select this external volume, we select a location, the URL of that, and then we create it. But here, instead of setting connecting an external storage account, we are going to use the internal storage account of Unity catalog. And that's why we will select managed volume. And once we create this volume as external, which connects to the real, the cloud storage or managed. So after creating, both becomes exactly same. The way they work in Databricks, so both the behavior, the coding, everything is same. That's why we will be using this managed volume here. Now this volume it is ready. Inside here we are going to create a directory which will be where we will be placing our files which we will be using as a source. So here we will be bringing in the transactions related data. So we will name it as transaction source. This will be our directory here. So I will click on create. And our directory it is ready now. So this is where we will place our file. And in the data that I have uploaded, I have created this file like blob transactions history. So let me upload this file here. I will click on upload. And now our source as a blob storage, it is ready. So now we are going to ingest this data. And to ingest the data from a file source, we need this path which is copied. So this entire path, it is copied once we click this button. And this time we are not going to use the ingestion pipeline or the Lakeflow Connect, because here directly there is no connector. And why is that? Because this file source, it is a file like a directory. So there is no standard way of maintaining columns, watermark, everything. So the files also can be in any format. So it is like a open-ended file source. That is why there is no direct connector currently. In future, maybe Databricks will introduce, but currently there is no connector. And that is where Databricks, they have previously brought in a very strong feature, which is called as autoloader. That is what we are going to use here. And to use the autoloader, we need to create a notebook. So let's go to workspace, and this is the home location. Here we are going to create a new folder first with the name retail underscore q. This is where we will keep all our important files. The folder is ready. Now let's create a new notebook here. And the name of the notebook, we will keep it as like blob to branch, which is consistent to what we are doing for other sources. And now we need to write the code here. That is how we use the autoloader. But instead of writing the code manually, that is where the next level AI coding assistant comes into picture, which is Genie code in Databricks. So that is what we are going to use here. So to use Genie code, we don't need to write any code. Simply we need to click this icon here. Once we click it, a window will open, and this is where we will be using the Genie code. And this Genie code, it has two variants like chat and agent. We have chat means it will just chat and reply to our questions. Agent means it can actually go ahead and make changes to our code. So instead of writing our complete PySpark code here, we will ask Genie code to write it for us. So let me change this language here to Python so that it doesn't write it as SQL. And to ask it to write the code, this is where we need to provide input. This input, it is called a prompt. So here we need to explain it what we are trying to do. Then it will write the code for us automatically. So here we will tell that we are getting CSV files at this location. This is the location that I had copied. Then I will press Alt and then press enter. So if we by default press enter, it will like send this much line to the Genie code. It will start doing its stuff. But we are trying to write a multi-line prompt so that we can explain what we are trying we are asking it to do. So now we will tell it like read the CSV files using autoloader and then write them into the target table, and here we need to provide the name of the target table. So far we have not decided the name of the target table. So first let's create a target schema where we are going to create our target table. For that I'm opening another tab. I will go to catalog, go to our retail catalog only that we had created, where everything is there. So for Postgres and Salesforce, we already have our schemas. So this is where we will create our schema. And this time we will name it as Blob Branch. So this is the source coming from the Blob Storage. So we will click create. And even like creating this schema, if we specify the exact name, we can ask Genie code also to create it. It will create for us. But it is better to create ourselves so that structure wise we understand how things are going. So here we will provide it like this much name, then dot. The name of the table we want to keep it as transaction. So it will create the table with this name. So this is the prompt we are writing. Now I will hit enter, or we can just click it. Now our prompt, it has been sent to Genie code. It is currently thinking what to do with this requirement. Now it is sharing its internal thoughts, what it is trying to do and what it needs to do. And now it is editing our notebook. So it is saying that it is trying to update this cell. And here we can see that it has written some code here, and it is running the code automatically also. And here we get this option. So if you are using Genie code for the first time, you will see this ask every time, and you will see a button to allow or reject it. Because I have selected always allow, so it is running the code automatically for me. You can also select it if you trust this Genie code. And currently it is trying to execute this code. While it is executing, we can notice that it has written this code which we can reject it or accept it. I'm going to accept it. Here it is trying to read stream spark dot read stream. It means it is the reading the data as a streaming source. And why streaming? So that next time whatever incremental data is there, then it will be able to read it. And this autoloader, originally it started with streaming, and then it was used for batch processing as well. The format, it is cloud files. So this format name, it is very standard. So if we specify this, then it uses the autoloader at the backend. And then the format of the file, because we had told it that this is the CSV, so it is considering the files available there as CSV files. And then it need a schema location as well. So based on the location we had provided, blob source, there it has automatically created a new folder underscore schema. So this is where it will store the schema of the CSV automatically, so that in future run it can know if there is any change of the schema or in the same format it is getting the data. And here it is saying like header is true. That means in our CSV, the heading line is there. Those it can use as columns. Infer schema is true. It means like it will be able to automatically infer the data type of the columns which are there. And then load. This is the source location where our CSV files are available. And this is just the reading part. If we move on to writing part, so once it create this reading data frame, then this same data frame, it is writing to the target. And while writing, it has this checkpoint location which it has decided automatically. So at this location, it is going to store some checkpoint related information, like which all files it has already processed, so that next time it don't process the same files, and it is able to process only the new files which are available at that particular location. and then trigger. So this is the type of trigger. Available now equal to true means process whatever files are currently available. And apart from this trigger, we can also specify some interval like 5 minutes so that every 5 minutes it runs automatically. Or we can specify continuous so that it will never stop. Whenever a new file is there, immediately it will process. So those are used for real time processing kind of scenarios. In our case, this will work perfectly. And then to table, it means whatever data it is reading, it will write the data to this table. This is the name we had specified. So this is how it write this clean, very effective PySpark code for us. It ran the code also. We can see it was executed, and now our table shall be there. So let's go ahead and check out our table. So if we go to the location which we had created for storing the bronze layer, here we will notice that the transactions table has been created. And if we check out the sample data here, and while this data is loading, we will notice that this Genie window, it is common what we were using there, because at any given point in time, we can use one instance of Genie code. So here we are not referring it, so we will simply close it. And we can see that the transactions data, it has been loaded successfully. And it has loaded all the columns from CSV file, and additionally it has loaded one new column which it creates automatically, which is rescued data. So in future, if we get any column in the table which is not fitting into the schema properly, or like there is less or more number of columns, so basically whatever it finds that it is not able to fit into table, so then it will put those rows as null, and it will put the entire data into the rescued data. So this is how it can handle any corrupted data automatically. So this is a feature of autoloader. And if we go back to our job, so here it is still like seems to be running. If we expand this, it is saying like it is trying to receive some records. So you earlier I thought it is completed, but looks like it is running in continuous mode, which is not normal. And it is here also, it is saying it is running this cell. So I was wrong that it is completed. So let me stop here from manually this one, and it is saying fail to run this cell. And this is the thing with the Genie code or any LLM that we use to write any code. It can make any mistake that like can run our code continuously like it is doing here, or it can make any other error in the code. So we have to review the code, and the code, it can make mistakes. That is what like they say is a disclaimer also, like always review the accuracy of the responses. So here instead of us figuring out what is wrong, let's ask Genie code only, and let's see if it is able to fix the continuous run problem. We can say the cell keep running continuously and never exit. What we want to do is I want to process the available batch and then exit, or like then complete execution. This is what we want. So let's see if it is able to figure out what is wrong and if it is able to fix it. And now it is making some changes into our code. If I accept it, so instead of directly like doing df dot write, what this is how like the code for autoloader has to be. So first we select this thing into a query, and then we write await termination so that it will wait for the batch to be completed. So now let's go ahead and run this code and see if this time it is working properly. And this time we will see that the execution, it is completed now, and nothing is running continuously here. And because we had not uploaded any new file, so the execution, it is complete quickly. There was no new data, so it was able to process it. And the locations we had specified here, like the checkpoint and schema, so let's try to understand those as well. So if we go to the place where we had uploaded our file, if I go one location back, so this is where the schema and checkpoint locations has been created. If I go inside schema, I will see another folder and then a file. So although we can't read this file, but this is where it is keeping track of the schema. It has some format of its own. And then if we go to checkpoint location, so this is where it is storing the information which file it has processed. So these are its internal file, but this is how it keep track of what file it has currently processed. So now as we understand it's working, let's try out some incremental load. So here we are going to upload one more file. And for that I have created another CSV file with 100 records. So let me go ahead and upload this one here in the same location. Then we will run our ingestion pipeline. So now the file has been uploaded. So let's go ahead and run our notebook code. So before we run this code again, first let's confirm the existing number of records here so that we can see that. So if I had hidden the output previously by mistake. So we can see that it has 1000 records. Now let's run this code again and let's see if those additional 100 records are coming here. So it has started the execution and now it is complete. So let's check out the number of records now. And here we can see that now it has those additional 100 records which we had uploaded as a second file. So this is how the incremental load works automatically in case of files using autoloader. So with this, we are done with the ingestion process. We have ingested two tables from Salesforce, two from Postgres, and one from a cloud storage. And if we go back to our architecture, so this part now we can say we are done. So next we are going to work on this data transformation piece. So as our data is there in the bronze layer, so now we are going to work on Lakeflow Spark declarative pipelines to build the silver and gold layers. So let's go ahead and try it out. So now I'm back in my workspace and let's go ahead and create our first Spark declarative pipeline. For that, we need to go to Jobs and Pipelines and then we need to click this ETL pipeline. So let me click this one. So once we click this, it will create a blank pipeline with very basic skeleton that it has. So if we see this, this is the name of the pipeline. So name, we are going to give it as, let's say, retail transformations, because here we will be creating our code mainly for silver and gold layer as well. And then we will notice that it has the folder named transformations, and then there is a file named my transformations. So this is a very basic syntax it has created. So this folder we are going to rename it. So instead of simply calling it transformations, we will call it as bronze to silver, so that we know this is where we will write our bronze to silver code. And then this is the name of the file. So here we will write the code table by table. So first of all, we will start with the product catalog table. Okay, so now finally we need to write the code. So as you may guess by now, we won't be writing the code ourselves. We will ask Genie code to write it. So here it is directly providing this option, or we can open it from right side as well. So, but the question is what code we want to write here. So now because we are loading the code from, loading the data from bronze to silver layer. So what normally the operations we do is, so first operation, let's say it is standardization related things. Like we select only the required columns, we provide proper names to the columns, and if there is unnecessary data, we can remove it at this point. If we want to create some new columns into the same table, and if we want to, let's say, cast some column to its proper data type, or any other generic transformations like converting dates, timestamps. So all these things normally we do between bronze to silver layer. And in addition to these core standardization processes, we also apply very good data quality checks. So that those all things, let's understand how we can do. So first things first, first of all, we will need the a place to read the table and then create our target table. So reading part, we are clear that we are going to read this bronze table that we had created previously. So let me copy this name. And for the writing part, let's create another schema. And because this is silver layer, it is more standardized. So now it will be independent of the source. So that is where simply we will call it as retail underscore silver. So it will be a common silver layer table for the tables which are coming from all the sources. So now this schema, it is ready. So let's go back and let's see here. So we will tell it that like read the streaming table. So the table which it has created by default, if we go there, right, and if we check out the Postgres table, so these are streaming table. So that is why we are mentioning streaming table. So we are saying like read this streaming table, and then let's say instead of mentioning each and everything, let's provide something generic, like let's say apply uh, generic standardization operations, apply some core DQ rules, then write the output to another streaming table. So the output table we want to create, that will be in this schema. So here let's give it a name, that this schema dot product catalog. So this will be the table it will create. So let's give it this prompt and let it write the code for us. So currently it is thinking what to do. It is sharing its internal thought, what it is trying to do. And then it is checking what all skills it has internally. Now it is reading the table structure, our source table, so that it can understand which table it is. And now after understanding each and everything, now it is updating our file so that it can provide us the code that we would want to run. And now it has written some code internally, and it is asking us to select the default catalog and schema, which we will select our target schema here. So this is our catalog, and this will be our schema. And now it is asking if we can go ahead and run the pipeline. For now, we will cancel it because first we want to have a look at our code. And although it is trying to run it again, let me stop it from here so that we can review the code first. So first let's see what kind of code it has run. Let me accept this so that coding wise these changes are saved here. And if we start looking at the code, for now let me close this right window. So these are some import operations, and then @dp dot table. This is a annotation that it is going to create a target table here. And DP means declarative pipeline. So it is a standard way of using this. Name, this will be the name of our target table that it will create. This is a comment about the table, what table we are creating. Then these are the data quality rules it has applied. And in terms of DQ rules, it can apply two type of rules. So one is expect. Expect means like it is expecting the supplier name to not be null. But if it is null, it will say that the data quality check is not matching, but it is kind of a warning. It will still let the record load into the target table. But here the second option is expect all or drop. So this is another way. So expect all means like there in single row we are applying multiple DQ checks, and here the rule is like product ID shall not be null and its length shall be greater than 0. Similarly, it has applied other checks for other columns like unit price shall be greater than 0 and some not null columns. So here, although it has grouped all the rules, so But when you are asking it to do the same thing, for you it may do slightly something different. And what exact data quality rules to be applied here? So think of this as a suggestion, but don't take this as a final thing. And especially like applying multiple rules, this is something like it can be better if we split it. So we will ask Genie to do it. So there is one other way to use Genie code also. So which is like to do something quick like here. So if I select this text and press Control I, or if I press this button, right, Control plus I is the shortcut. So now what it will mean is that it understand that this is the part we want to make some changes. So we will say like split the rules into individual rules. So now only this part it will make some changes. That is how this smaller version of the Genie code works. And after understanding what we are trying to do, it has split our rules into like multiple lines here. So instead of expect all or drop, here it is applying these as individual rules. So here we can like control these. For example, if based on unit price, if we do not want to drop the record, then we will simply use expect. And same way, if let's say category also we don't care much, like we want to know, but we will let the data proceed. So then we will not drop it. So this way we can control it when we are applying these data quality rules individually. And again, as I was telling, these are suggestions. What actual or like more data quality rules can be applied to our project? So that depends on the project to project or what data we have and what kind of quality checks we would want to apply. But these are some generic ones that it has suggested. And then for some of the columns, it has tried to apply some like a standard operations. So let's try to understand those as well. So here for this product ID, it is doing a trim and then it is trying to convert it to uppercase. But this uppercase, honestly, we don't need it. Trim also, we don't need it because in our source, we know that it is coming in the right form. So we can simply ask it to like remove the upper and trim operations. So it will simply remove it for us. And this way we don't have to like worry about the syntax or manually editing the code. We can quickly edit the code however we want to. So now it has removed the operation. It is selecting the column and giving the same alias. Again, this is not required. Simply we can use the column itself like this. Then here what it is trying to do is product name. It is trying to trim it, like removing the space if it is there before or after the product name. Init cap mean the first character of the value, it will make it as init. That is what it is doing. Similar operation it is trying to do for the category here, and for subcategory it is doing similar operation. And then it is saying like if it is not null, then it is trimming and init capping. Otherwise it is filling with the keyword unknown. So wherever it is null, it will be filled with the word unknown, which is good. Similarly it is doing for the brand thing and the unit price which is there. So it is trying to round it off to 2 decimal points, so which can be better for visualization and whoever is looking at the data. So this we can use it as a standardization. Same thing we are doing for with supplier name, a launch date we are not making any changes. Is active column we are doing something, but this is active column which is coming from the source. So we would want to apply this as a filter. Like if the this thing is not active, then we will filter it out. And because this table, if you still recall, it was SCD type 2. So that is where we will want to like take only the records which are still active, like where the end date was not populated. So that kind of operation also we would want to apply there. So let's ask it. So first let's make this change. So I'm copying this is active, and then I will select this much of code so that like it will apply that as a filter. So we will say like remove from target table and apply this as filter and take only true values. That is what we want to do here. So now it is making the changes on the fly. You can see it is trying to do those things. It has removed it from here, and at the top it has applied it as a filter condition. So that is what we wanted. And now what we want is we want a new column. Sorry, I will put control I now. Now what we want is like add a new column is active, uh, which is based on the end 8 column, whether it is null or not. Also add the start and end 8 columns as it is. If we want those column also to be available here. So that is what we are trying to ask it now. And now it is making changes accordingly. And here we can notice that it has made the changes, but because currently it does not know the schema of the table, the column names, it is not taking them properly. So that is something we will have to ask it to review the schema so that all the columns it can use properly. So for that, we will copy the source table name here, and then we will ask it here like analyze the column names and schema and confirm if all names and let's say operations are looking good or not. So now it will understand the schema of our table also and see if there is no grammatical or like typing mistake in our code. So it has understood that these are the all the columns which are available in the source table, and then it is checking whether each and every column it is existing or not. Now it is trying to fetch some sample data so that it can understand the data also, so that that way it knows whether it is doing the operations in the right way or not. And now it is saying like some issue it has found, and it is asking whether it can fix the issue or not. So we will say simply go ahead, so that it go ahead and fix that issue. And now it is trying to make some changes to our file. And here we can see that it has made some changes. Now it is using the proper column names, and it did a dry run of the pipeline, and now it is trying to run the pipeline also. So still we don't want to let it run. I will cancel it. I will stop it. Because dry run is successful means like there is no error in the file. But before we actually run this pipeline or this file completely, so this is some code that it had generated automatically based on some basic details. Now let's say we have some business requirement that we want to add a new column. So the column itself be like product segment, and depending on the unit price, if it is greater than 50,000, we call it as premium. If it is greater than 10,000, we call it as mid-range or budget or this. So this kind of custom requirements can also be added. So this is a column derivation that we are doing in the silver layer. And with this, now we shall be good with our pipeline. So let's go ahead and run it for this one table. So let me close this Genie code and let me run our pipeline now. Now let's provide it the catalog and schema name so that it can use those as the default catalog and schema. So now it will go ahead and run our pipeline. And now looks like the pipeline it failed saying permission denied. So this I got yesterday also. So what is happening is that there is some kind of issue going on with this Databricks free edition. So in like paid version it will work fine, but in free edition we need to find a workaround. And the workaround, although it is simple, it may seem strange. So I'm going to copy this entire code and we need to create a new pipeline. So sometimes it is happening with the pipeline. Whenever we create a new pipeline, then this kind of issue are fixed. So let's go ahead and let me give a new name this time. So previously it was retail transformations. Now let me give it as V2 maybe. And here this folder name we can rename it. So it was bronze to silver. And then the file name we can give it any name. So yeah, the same name we will use, which is product catalog. So here let me paste the code that was there. And above here, we need to select the default catalog and schema. So let me select that our target catalog and the target schema that we had. And let me save it. And now let me go ahead and run this pipeline from here. So this time it seems to be working. So as I was telling, it seems to be some bug in the free edition. So if you are not getting it, you are lucky. Maybe by that time they may have fixed it. But if you are getting it, so simply create a new pipeline and paste the code. Then it will work fine. And now the execution it is complete. So let's understand this execution in detail so that we see everything what is going on here. So first of all, if we look at these statistics, so this is the table which is created in the target. And here, this is the duration. In the target, it has written 23 records and expectations. The expectations we had set. So it is saying 4 are met, 2 are unmet. So in total, we had set up these 6 expectations. So if I click this, it will show that it has written 23 records and it has dropped one record. And here we can see the failed expectations. So valid price, it failed for one record. So valid price, it was like price greater than 0. This is the name, like this is the name it is showing in that chart, the name of the DQ rule. So price, it maybe it was 0 for one record. So it didn't, it the action it is saying it allowed that record. So the record is there in the target table. And why? Because we had set it up as expect, not expect or drop. And another thing is like valid product name. So for product name, we had specified it shall not be null and its length shall be greater than 0. So when it found one such record, so because here it was expect or drop, so it has dropped that record. So action it took is drop. So that means wherever the product name was blank or null, it has not loaded that into the target silver layer. So this is how the two different type of data quality checks can work in these Spark declarative pipelines. And here we see this all option also. So if we see here, we can see all the 6 data quality rules which were applied. And we can notice that for these 4 rules, nothing failed. So every expectation was met, whatever is defined here. For these two, one record it failed. And so here it dropped one record, here it allowed one record. So this was the configuration. So this is how to understand these data quality checks here. And this is the, I would say, power of this Spark declarative pipelines also, because just using this one syntax, how easily we can define a data quality checks. We can even decide whether to drop it or allow it. Everything is configurable. It has been made very easy. That is why it is getting very popular now. And if we want to check out our target table, so we can click here. It will take us to the table which is created. Here is our table. And if I click on sample data, it will showcase the sample data to us. So here we can check out the sample data. We can see the 23 records which has been loaded. And here we can also notice that the start and end date columns it has added, and it has added the is active column also. So wherever it is null, it is saying true. Where it is there, it is saying as false. So that means this record is not active anymore. So with this, one of our silver table, it is ready now. And now let's work on our second silver table. I took a break, I had logged out. So if you also do the same, and if you want to figure out where to find the pipeline that we had created, so for that we will go to this jobs and pipeline section back. And here we need to check the pipe based on the pipeline name. Here we have these sections as well, like all jobs pipelines. So the ETL pipeline we created, that comes under the pipeline section. And this was the name we had given, like retail transformations v2. So from here I can open it again, and currently we can see that it is showing the one table that we had created. Now I'm going to edit this pipeline, and here it will open the same editing screen that we were using previously. And currently, as I was telling about, we were using only one uh, table here. So let's create one more file. So I will click on this, then create file. And this time we will do it for inventory table. So this file also, let me name it as inventory. And then here we need to like bring in the same code. We can create the code in the exact similar way using Genie code. But this table, it is very simple. There are not lot of things we are going to do. So I'm going to paste here one of the code that I have created previously. I will explain it line by line. I have uploaded also, so you can also use the same. So here these are simply the import statements. Then same way, this is the name of our target silver table. This is a comment, what data it is containing. These are the data quality checks. So if inventory ID is not null, then it will pick up. Otherwise, it will drop the record. So here we are using expect or drop, so that if it is not matching, it will simply drop the record. And these other checks like stock quantity must be greater than equal to 0. So it's let's make it greater than 0, because it has to be positive. Stock shall be there. And then product ID shall not be null, store ID shall not be null. These are kind of a optional check we are doing, so that we know how many records we are getting this way. But here it will not drop the records if these checks are not matching. Then this is the main function which will return, or which will define what data it is going to load into this table. So here again we are reading our streaming table, our bronze inventory table. And then in the return, most of the columns we want here as it is, because this is a the table itself, it is currently very clean. There are not lot of things we want to do. And this table, it was SCD type 1 only, so the end 8 or is active kind of columns also we don't need to create. But here simply one additional column we are adding here, which is like if stock quantity it is less than the reorder level, so then we are saying it is low stock. Otherwise we are saying it is healthy stock. And this column we are calling it as inventory status. So the reorder level, so that is a column which is there. And how it works is that if our quantity falls below the reorder level, it means like we need to make another order and increase our stock, so that we are able to fulfill the demands. That is how this is important. So this column, it will tell us how many stocks are there with low stocks and how many are with the healthy stocks. So this is the only thing we will be doing for this particular table. So now let me go ahead and run this pipeline, so that it will load this table. And the thing to notice here is that when we run the pipeline, it will run all the files which are part of the pipeline. So even though we had run product catalog, it will run it again. But this, because these are streaming table and we are using Spark declarative pipeline, so automatically it will load incremental data. We know we don't need to worry about like capturing the watermark or doing anything. Those things it is able to take care internally. And that is why for product catalog, we are not expecting any data to be loaded because already it has been loaded. And for inventory, because this is the new table we are creating, so now the data will be loaded. So the pipeline, it is complete now and as expected. So there is no data load for product catalog. For inventory, data has been written for 43 rows. And if we go to the expectation part, so we can see that these three things it found unmatching for one record. So there was one store ID which was null, one product ID which was null. And in one place, the stock quantity is not greater than 0. But based on these checks, we were not dropping our record. So it is not going to drop it. It will allow that record. And that is why there is no drop in the record. Everything 100% records are written into our target table. And this other checks that we had applied, it is satisfying for all the records. So that is why no record has been dropped off. So now let's move on to our third silver table. And this time we are going to work on a Salesforce based table. So let me create a new file here. And we will name this file as account because we will be working on the account table now. And for this also, I have prepared some code. So you know, right, how to prepare this code using Genie. So to save some time, I'm just pasting here, but feel free to create your own. And because if we create using Genie, it will create something similar, which may be like slightly here and there. So that's not a big deal. For this table, simply like here we have import statements. This is our table name, the comment, and here we are only setting two expectations. One based on which we will drop the data if it is not matching, and one which is a warning kind of thing. And then this is the function, this is the table we are reading. And for Salesforce tables, there is something about the naming convention. So if we look at these names, here they follow this Pascal cases where like there is no underscore and they use upper cases. But in data lake, normally we follow lower cases with underscore as a separator. Those are the standards we follow. And that's how we are getting data from our Postgres tables as well. So if we look at the product catalog, so here automatically we were getting the columns in this form. So this is a good opportunity for us to rename our columns so that the columns also they follow the same standard. So that is why we are renaming these columns to change them to lowercase and underscore. And here the customer name column we are changing to uppercase because we want to see it in uppercase. And if you notice, so in the source the name was simply name, column name. Here we are naming it as customer name because now we know it is a customer. So we want to use our own column names here. And then these columns simply we are changing them to standard configurations. Standard naming conventions. And then in the industry column, sometimes wherever it is coming null, so we want to say that as unknown. So this one thing we are doing here. And because this table was SCD type 2, so here also we are adding a new column named is active. And based on the end 8, if that is null, then it will be true, otherwise it will be false. So that is how we are creating. It is similar to what we created for the product table. And here we are doing one other operation which is directly not visible, that is column pruning. What it means is that here we are specifying only the columns which we really need. So if we look at our source account table, which is coming in the bronze layer, so there are so many null columns which are coming by default from the standard Salesforce. There we may or may not be using each and everything. But these kind of columns we will not be needing in our case. So those columns we don't need them in silver layer because we are not using them at all. So that is why not selecting those columns also, it makes our silver table clean and easy to read once it is created. So with this, the code for this table, it is ready. So let's go ahead and run it now. And while it is running, let's parallelly create another file. And this time we are going to name this as opportunity because that is the table we will be working on. And for opportunity, let me put the code here. So this is the code that we will be using. And the code structure, it is similar only. These are imports, the name and comment. And this time there are some different DQ rules that we are applying here. That the ID column shall not be null, the name it shall not be null. And if ID is null, then we are not even allowing in silver table, we will drop it. If name is not null, we will consider it as a warning, but we will allow it. Similarly, the amount it shall not be null and it shall be positive. That is what we are specifying here. And the probability column, that also shall be positive and less than 100. And there are different stages of our order. So it shall be one of these values only. That is what we are interested and we are seeing. If there are other stages coming in, those will be flagged as warning. And here intentionally I have not mentioned all these stages so that some of those we can see them as warning. And then comes the function where first we are reading our bronze table and then we are selecting our columns. So because this is also a Salesforce table, so the naming convention, it is similar to the account table. So here also we are renaming the columns wherever required. And then here, this is a business requirement that we want to add a new column here. If amount it is greater than this value, then we call the deal size as enterprise. If amount is greater than this, then we call it as mid market. Otherwise, if it is less than this, then we call it as small. So that way we are adding a deal size column so that directly we can know how many deals are of enterprise size, mid market and small size. And then these rest of the columns, these are just renaming as per our standards. That is what we are doing here. So this is the code for this file. And before we run it, here one thing to notice is that here this icon is appearing. So here what happened is instead of clicking on the create file on this inner folder, I clicked on the outer folder. So this file, it is created outside this bronze to silver folder. And that one by default, it is saying that it will skip this file when we run the code. So whenever this icon appears in SDP pipeline, and if we click this run pipeline option, it will run other files, but it will skip the run of this file. So to make it run directly here, we can change it. We can select this option like include as pipeline source code. Then it will be included and this icon will be gone. And in our case, because we need to put it inside this folder, let's see if automatically it changes. Yes, it changed it automatically also. So that way it will be included now. And if we want to exclude any file, then here at the file level, currently it is disabled because this folder we have enabled. But folder level, we can exclude it. If we exclude it, then that entire folder will not be executed. So now this file, it is ready to be executed. And before we run it, based on our previous run, we can see the output here. So for account table, 51 records has been written into target and expectations wise 2 are met. So there is no failure or any records which is not as expected. So it has not found any such record. So that is why everything is as expected and the data load is complete now. So now if we run the pipeline, so this opportunity table is new. So this one, the data will be loaded. Others, because there is no incremental data, so nothing will be picked up. And now the execution, it is complete. It has written 100 records to the output table. And if we check the expectation, so it is saying like these two are not met. So the stage name, right? Like I was telling, so I had intentionally not put all the stage names here. So it is saying for 64 records, the stage name is not within these three values. And the amount, it is saying for 3 records, it is either null or it is like a less than 0 negative value. That is what it is trying to say here. And the other expectation we had set up, these three, these are met. So there is no record found which is not matching our expectations. And if we want to check out if our table is created properly, same way we need to click this icon. So it will take us to the new tab. And here we can see the new table which has been created. So in our retail silver, now we have our 4 tables created, and the naming convention, everything, it is very standard now. We can check out some sample data also to confirm that the data has been loaded properly. And here we can see the data also, it looks really good now. And you see now, right? So after removing the lot of null columns, so the table, it looks very clean. We have to scroll less, and this is the real data that we are interested in. So that is the intention behind any silver table. So the data, it has to be quality checked, it has to be clean, it has to be standardized. And now as we are done with 4 tables, both from Salesforce and Postgres SQL, now we are left with one transactions table which is coming from CSV files. So now let's create a file for that one. So this time I will create from this folder so that the same issue doesn't happen again. And the name of the file, we will give it as transactions. And now let me bring in the code for the transactions table. So here the usual stuff. After that, these are like similar quality checks we are doing. So transaction ID, it shall not be null. Quantity shall be greater than 0. Selling price shall be positive value. Discount amount shall be positive value. And product ID, it shall not be null. And the payment mode which is there, it shall be one of these 4 values. So these are the quality checks we have applied here. After that, here we are reading our transaction table. And then, so here the naming convention wise, these are already standard. So simply we are selecting the columns that we need. And this is like another use case for silver layer. So here we can derive new columns in silver layer. So here we are multiplying the quantity and selling price. So that becomes our gross amount. So that directly we can use the gross amount column. And also the second thing we are doing is the standardization. So this transaction timestamp, which is there in the bronze layer, that column currently it is available as a string. So if we check out the existing data for this table, and if we check out the transaction timestamp, because this data it is coming as a CSV file, so it is coming in a different format, and by default it is treated as a string. And apart from this column, also we notice that the numerical column which are there, like quantity and all these are also not inferred automatically using Spark. These are also coming as string type here. So these 3 columns, we will need to cast them to integer so that we can use the aggregation operation on these later on. So let's go back to our code now. So this timestamp, using this to timestamp function, here we are specifying the format which is coming in the data. So it is like date, means like the 3-digit month is coming, then year, hour, minute, second, and whether it is AM, PM. So those values are coming here. And this to timestamp column, it will convert it to actual timestamp column. And then with this name, we will store it in our table. And also these columns, we wanted to convert them to into numeric values. So I will select this, press Control I so that we can use Genie code for the same. So cast these columns to integer type. So it will automatically cast it for us. We don't have to manually write any code. So with this, the casting, it is done now. We will accept it. And now the code is ready. So we will go ahead and run our code now so that this transactions table, it is populated properly. So here we can see that records has been written. So 1.1k records has been written. Here are the data quality checks which are there. So here whatever failed, it was able to allow those records because transaction ID part we were good. For others we had not selected the O drop part. So it has not dropped anything. But these are the number of records which are not matching the quality. And if we check out our target table from here, so this is the table created. Let's check out some sample data as well. So now we can see that data has been loaded properly. And also this quantity, selling price, and these amount columns. Now these are coming as integer type instead of string. So we are good here. And the transaction timestamp column also, now we can see that it is coming as the proper timestamp column, so that whatever operation, timestamp or date related operations we want to do, those we will be able to do it now. So with this table, now we are completely done with our silver layer. Next, we will focus on the gold layer. To work on the gold layer, as initially we were discussing, so we are going to build the gold layer as a standard star schema. So if we notice this star schema, here we will see that we have a table dim product, which is like directly coming from this product catalog table from the source. We have this dim customer. This customer table will be coming directly from the account table. So in terms of Salesforce, these things are called as account, but in general, our naming conventions, we call those accounts as customers. So this is our dim customer. So these two are one-to-one mapping with our silver table. And then we have this new table, which is a calendar table. So this table, we are not bringing this one in from any of the source, but having a calendar table, it is a very standard practice, so that like whatever operations we want to do based on dates, year, months, those become very standard once we have a calendar table. So this table we will directly build in our gold layer, so that we can use it. And this kind of table we only prepare it once, because this is the like for every day there is one entry which is never going to change. So we just prepare it once. And then this is the most important piece, which is the fact sales. So this table, it is a combination of our transactions and the orders. So when I say transaction, so transactions are directly coming from our CSV file. And when we say order, so orders is nothing but the opportunity table. So in terms of Salesforce, we call it as opportunity, but these are nothing but the orders which has been placed against those accounts or customers. So that opportunity table and the transactions table, these two we are going to join and then build our fact sales table, so that this will become our central table for the star schema. And this becomes our standard star schema because we have central fact table and we have 3 dimension tables which are surrounding this. And in terms of data modeling, there are two type of schemas which are used enterprise level. So star schema and snowflake schema. So star schema, we already know there is a central fact table surrounded by the dimension table. And if any of the dimension table, it further has any other dimension that it can be it can be mapped. So instead of storing everything as a single dimension, if this table joins with this, then this joins with further any other table, then it becomes a snowflake schema, because we have a fact table surrounded by dimension table. Those dimension table are further surrounded by other dimensions. So that kind of schema is called as snowflake schema. So here we are building a star schema, so we are good. And here there is one table which we didn't discuss currently, which is inventory table. So this inventory table, currently it doesn't directly fit into our this star schema table. But having this table, it is very important. And practically also things are like that only. Like whenever we are building something standard, so some things will fit right into it, some things may not fit it, because practically that's how things are. So this inventory table, we will use it as it is. We will use it in our dashboard and everything else, but in terms of the standard fact and dimensions, we don't require that table. So inventory itself, it is a fact table which may or may not be joined with other dimension. It depends on what kind of analysis we want to do, but currently we will focus on these four tables first. So now coming back to our pipeline, in the same pipeline, we will build our gold table as well. So bronze to silver part, we are done here. Now let's create another folder here, which will be silver to gold. Let me directly create it. Now inside this, we will create our gold table. So if I click on create, I will create a new file here. And first we will directly start with our central table, which will be fact sales. And to build this table, this is the code that I have prepared. So this is the standard stuff. After that, as I was talking about, we will be joining these two tables. So we are reading both the tables here. And then I'm joining the transactions data frame or table with the opportunity data frame. And the joining column we are using here is the opportunity name. So one thing we will notice here is that there is no directly ID column which we can use for joining. And the reason for that is because one table, the opportunity table, it is coming from the Salesforce source, which has its own IDs generated. And transactions data is coming from another source. So that is why they don't have a matching ID. But if the data belongs to the same order or same opportunity, that is how we can join them. So that's why we are using the opportunity name for joining. We are using the left join here because we want to keep the granularity at the transaction level. And for each of the transaction, we want to keep all the entries. We don't want to lose anything. So that is why we are using left join. So after we get this join data frame, then we are selecting the columns which we are going to need. So these are the columns which we are going to use from the transactions table. And then these are the ones which we are going to use from the opportunity or orders table. And here one more column we are driving from the timestamp is the date column. So this transaction date column, once we calculate in the gold layer, so this column we can directly join it with our calendar table so that like there is direct one-to-one map, sorry, many-to-one mapping that we are able to build there. So after selecting this data, that is what we are returning. So that is how it will prepare our fact sales table. So with this, we are good for this pipeline. So let's go ahead and run it. And here, even though everything is completed, but this fact sales was not run because of this thing. So I forgot to activate it. The same thing I was explaining you earlier. So let me include this in the source code so that this also runs. Now we are good. So let me go ahead and run this pipeline. And while it is running here, we can click this icon here also so that whatever data it is running, it can showcase us like how it is linked, which thing is running and not running. And here we can see that the lineage part also it is able to showcase us automatically. So for silver layer, it is loading these 5 tables. And this gold layer which we had built, so it knows that it depends on these 2 silver layers. So automatically it is running after these 2 are complete. So we didn't have to specify anything. It is running these after that. And then we will be able to just check out this table. So if I click it, so we can see that fact sales table, it has been run now. And if we want to check out the data, we will click that icon and it will take us there. And with this, our fact sales table, it is ready. And we will notice that the retail gold, it has been created. And then we have our table available here. So let's check out some sample data to confirm if everything is looking good. So here we can check out the sample data and we can see the data has been loaded properly. For every transaction, we have the opportunity name, and the columns from both opportunity side and the order side are coming properly. So we are good here. Sorry, not order, the transaction side. So the data, it is looking good and clear now. Now moving on to the other tables. So as I was talking about, so in this table we had to join two tables, but the other gold table like dim customer and dim product, those tables are one to one mapping with silver, and the tables in silver layer, those are already standardized, those are already clean, they have a good naming convention. So for that reason, we don't need to just copy paste the data again to gold layers just to like showcase that it is a table. So practically what is a better solution is that for such table we will create it as a view so that the data is not replicated again. We can still use the same data from silver layer, but using a view it will be presented as a standard dimension with proper definition. So for that reason we will create those as view. So let's go ahead and see how we can create those as a view in Databricks. So to create the gold views, I have created a notebook because this code we need to just run only once, and then the views will be ready, and we don't need to create them again and again. So whatever data will be there in silver, it will be automatically available in the gold layer. So first of all, we will create the view of customer. So create or replace view, it means it will replace the view if it is already there. If not there, it will create it again. This is the catalog, the schema, and then the name of the view it is going to create. As this is the data it will put inside that view. So here we are selecting the data from the our silver account table, and we are applying a where condition where is deleted is shall be false. That means that the data shall not be deleted. It is a marker coming from the Salesforce side, and the is active column it must be true. So this is the SCD type 2 that column we prepared. So we want to pick up only the records which are currently active so that we see the dashboards and everything based on the active records only. So these two filters will be applied after reading the data. And then these are simply just the columns that we are going to read from the table. And the ID column, we will name it as customer ID so that it is more readable. And type also, we will name as customer type. So now I will go ahead and run it. And then it will create this as a view in our gold layer. So the execution, it is complete now. Now our view shall be ready. So let's check it out. And here one thing is that now we have renamed the account also to dim customer. So having the terminology customer, it is more user friendly. So if we go to our catalog and let me refresh from here. So apart from our fact sales table, now we can see the dim customer, which is available as a view. And we check out the sample data here. We can see that the data is coming properly into this view. So our gold view, this one is ready. Now let's check out other views that we are going to create. So similar to customer, we have this dim product view that we are going to create. It is going to read the our product catalog silver table. It is going to pick up is active equal to true and then select these columns. So this again, it is a very simple view. So let me go ahead and run it. And here looks like I mistakenly gave the wrong table name. So after correcting, let me run it again now. So now it is created properly. And moving on, so the next one is inventory. So like I was talking about, so although we didn't fit inventory table into our standard star schema, but still it can be used to analyze the inventory related information. So for that reason, we will create this also as a view. So now we are done with our core fact and dimension tables. Now we are left with our special dimension table, which is calendar table. And as I was talking about, so this calendar table, we are not ingesting it from the source. We are going to build it in Databricks only. And to build it, we now have the Genie code to help us out. So let's provide some information. So let me copy the catalog name here, catalog and schema name, so that we can specify to Genie code. So to use Genie code, I will click here. It has opened a new chat. So let's ask, let me tell it that I want to create a calendar table in this schema. This is the schema that I have copied. And then we are saying that it shall have a date column of type date, which will be key column. And then we can say that add other columns based on date, like year, month, week, which are standard columns used in like generic calendar tables, so that automatically it can decide which columns we are going to use. And what we also want is, we will say that like provide start and end date is input, so that I can decide how much data to be populated. So this is our requirement, that we want to create a new table here. It shall have a date column, which will be the primary column, and then it will add some other columns which are standard. And then it will also provide us a start and end date as input, so that we can decide how much data shall be populated into this table. So let me go ahead and provide this prompt. Let's see how it is able to come up with the calendar table idea. So now it is thinking internally what all things it need to do. And now it has added two input parameters like end date and start date. Based on that, it will populate our data. And here it is done with the code, and it is saying like, can it run the create or replace table statement? So before allowing it to run it, let's review the code once. And here in terms of date, the data that I have currently prepared, it mainly belongs to 2026 years, 6 year. So the date we are going to use is like 2025 to 2027, or let's say 2028, it doesn't matter. So so for these 3 years of data, it will populate this table. And let's accept this notebook first, and let's see what it is trying to create. So it is saying it will create or replace this table, and then with the date range is, so it will explode this date range. And it is what it is doing is, it has prepared a sequence from this start date to this end date. Interval is 1 day. So for from this start to end date, every day it is keeping one entry that it has exploded means for each of the entry we are getting one row for that. And then from this date range, it is trying to calculate all these columns, so like the date, year, quarter, month. So all these entries it is trying to calculate. That way it has prepared. So now the code, it looks good to us. So now we will allow it to run this code. So now the code has started to execute, and now the execution is completed. It is trying to check out some sample data automatically. And here we can see that it has fetched some sample data, and it is also trying to do some additional checks based on the data, and it seems to be satisfied. So now it is replying to us saying that it has created this table. It has the data for these many days from this date to this date. And then these are the columns it has added. So this is how Genie can come really handy when it comes for any new development. And our side also, let's confirm if the table it is created properly here. So if I refresh from here, here we can see that the calendar table is created now. And let's check out some sample data here. So here we can see the sample data. For every day, there is one entry. We have columns like year, month name, and week wise also. If we want to do something, we have the data. Week of year, month, and day, it is there. So it has prepared so much detailed table. Honestly, I was not expecting this much detail, but having all these details is really good. So now this dimension table also, it is ready for us. And here we forgot to add the dim keyword to make it standard. So let's directly rename it from here so that it is created as a dim calendar table. And with this table, our gold layer, it is complete now. We have our fact tables, we have our dimensions tables, and these are as per the standard star schema now. So we can say that the gold layer, it is ready now. And now if we look at our architecture, so we can say that data ingestion part, it is completed. Transformation part also, it is completed now with all the standard bronze, silver, and gold layers that we have built. And the next item we are going to work on is the semantic layer. We will build the semantic layer using metric views. So before we build it, let's understand what exactly is metric views and what is semantic layer and why we need it. So the standard definition of metric views is that they provide a centralized way to define and manage consistent, reusable, governed core business metrics, which are dimensions and measures. So metric views, this is a new service provided by Databricks, recently launched. So it provides a very standard way of defining the dimensions and measures, so that if we have same measures or some dimensions coming from multiple sources, they have different definitions, the different standards they are following. So in metric views, we can create everything in a very central and managed way, so that we can control what measures are there, what dimensions are there, and their definition we can provide in a very standard and efficient way, which we will check it out. So what technically how it works is that, like, we have our Unity catalog views and tables that we currently have. It also supports other metric views and foreign tables. Then we define a metric view using a combination of YAML and SQL. Here we won't write the code manually. We will use the Genie code. But this is what is used to define a metric view. And when we define it, we define the dimensions and measures there. And once those are defined in a metric view, then we can use those metric view through SQL queries only, and we can use them anywhere. We can use them via code in SQL, Python, or Scala, or we can directly use them in the dashboards, Genie spaces, and multiple places we can use. Wherever we want to use the data, we will use the data in this standard form. So now let's go ahead and create our metric view in Databricks. So here we know that these are our gold table. And for the semantic layer, let's create a new schema first, where we will create our metric view. So I'm going to click on create schema. Schema name, we will mention it as retail semantic. And here directly also we get an option to create a metric view. But instead of creating manually, we will create it using Genie code. So for that, we need to write a prompt. So first let's prepare for the prompt part. So this is the fact table we are going to use. So in a notepad, first we will write the prompt in proper way. Then we will provide it to Genie code. So we will say that I want to create a metric view with name is, let's say, retail metrics. In this schema name I will copy paste. We will say that, like, read the following table schema and sample data, so that it understand the data columns and sample data properly. And here we will provide the table names. So this is one table, Then inventory table we will not include because it is not part of our standard star schema. So we will use the product table. Then we have the customer table. And then we have the calendar table. So after it analyze all these, then we will say like decide the dimensions and measures based on the data, and then create it as a metric view. So this is what it will create. And where we want the metric view to be created in the retail semantic schema. So here I will provide this schema name. So now I have this prompt. So this is what I will give it to Genie code. So I will open the Genie code here. And then I will ask it to create that metric view for us. And here it is showing the previous chat. So I will click on new chat here. So whatever work we are doing, if we are starting a new work, then using this new chat option is really useful so that it is not confused that we are trying to do something similar to previous operation. This is something very new we are trying to create. So we shall use it as a new chat option. So after providing the prompt, it is currently thinking what it needs to do, and now it is seeing what it is what skills it has. Now it is reading the table structures based on the table that we had provided. Now it is saying like it has gathered the schema information for all the 4 tables, and it is trying to create the metric view now. So this is the YAML file it has automatically created. YAML, and then this is a combination of YAML and SQL. That is how we create a metric view. And it is saying like it has created the metric view for us. So if we click on this open metric view editor, it opened a new tab, but it didn't really open the metric view editor. So what we will do is we will directly go to our semantic schema that we had created, and let me refresh it here, and let's see if our metric view is created. It is still refreshing. Let me refresh from the top maybe. And here looks like it has not actually created the metric view yet. So what we are going to do is this code that it has generated, we can run this code ourselves. So I'm going to copy this code, and then let's open a notebook there which we can run it. So these are our other notebooks that we have previously created. Let me create one more here. We will name it as metric view. And this is the code it has generated. So first let's try to have a look at the code. Although it looks like YAML code, first look maybe it may be looking a little bit complex, but it is pretty simple. So this is the name it is trying to give to our metric view. And it is saying it is a sample, but where we want to create is in retail queues, retail semantic schema, we want to create it as retail metrics. That is the name we want to provide. Then with metrics, language YAML is version. This is something standard format for for creating the metric view. Then comes the source part. So this is our source fact table. It's a comment about this table. Then this table, it is joining with product table. Uh, so this is the name it is giving, and source, this is the actual product table. It is joining based on the product ID. Then it is joining the calendar table with the this source table based on the date column. Transaction date, it is joining with the date. And then it is creating the dimensions and facts. So here one thing we notice is that it has not yet joined the customer table, which is very important for us. So first let's see if there is like the customer ID is there so that we can join based on that. And if we let's go back to our fact table there. So this is our retail gold. if we go to fact sales table, and uh, here we can see that the customer ID column, it has not been added here. So I think we missed it when we worked on the gold layer table. So let's go and let's open our pipeline first. So if we go to the jobs and pipelines, this is the pipeline we had created. If I will click on edit pipeline, and this is where we had created our fact table. And the column we are looking for, that is available in our opportunity table. So if we go there, if we open our silver opportunity table, here the customer ID is available as account ID column here. So let me copy this, and here we will say that like add that as well. So I will put control I, we will say add the column account ID is customer ID, so that it will add that column here. And with this it will be added. So let me accept this change. Let me run the pipeline so that the account ID column is available now. So the execution, it is complete now. And if we go to the fact sales table, so now we can see that the customer ID column, it is populated. So now we will be able to use the customer table as well. So let's go back to our metric view. So here we will ask Genie to include that as well. So first I will copy the name of this dim customer table. Then I will go there. I will say that now it has already created this. So let's start it as a new chat. And we will say that in this metric view, include this view also, which can join based on customer ID with fact sales. It can figure out maybe the joining column automatically also, but if we know it, providing is better. And then we will say that include shoe table dimensions and facts, dimensions or facts from this new table also, so that it consider that table also in scope. So first it is trying to understand the structure of the dim customer table, and now it is going to edit our metric view. And we can see that it has made the change to our notebook also. So now it has included the customer table which joins based on the customer ID, and then it has added some good dimensions and some measures also, which we will understand one by one. But I think coverage wise all the tables are covered now. Now before we go into detail of this code, let's run it and let's confirm whether the code wise we are good, there are no errors. So now our code execution, it is complete. The metric view is actually created. First let's check out the metric from the UI part. So we will find this one also in the catalog, because this is also a catalog object. It will be created similar to our tables and views. So if we go to our retail catalog, then this is the schema we had created. And here we can see our metric view, it is created now. And in the overview page, now we can see that it has created these 6 measures and then 15 dimensions it has created for us. So all these things we can directly check it out here. And on the right side here, we can see the source. What is the source of this metric view? So the main, it is this table, and there are 3 tables being joined. We are not using any universal filter. And if we go to the detail section, here we will see the YAML definition, the same YAML definition which we ran while querying this metric view. So using this only it is created. And if we go to the overview, if we try to understand the measures and dimensions, so if we look at the measures, we will see that here the measures are like transaction count, total revenue, total quantity, so how much quantity we have sold. This is the comment or explanation of the that particular measure, like total number of items which has been sold, then total discount, average transaction value, and then unique customers or number of customers. So these are our measures. So measures are basically the quantitative values which represent like the sum average of the important numeric columns. And then dimensions, these are like our dimension or the entities based on which we would like to know our quantities. For example, we may be interested to know like what is the average transaction value per year or per month or for each brand. So that is how these are the dimensions. Based on these dimensions, we may be interested into calculating these measures. And this is where the power of metric view comes into picture. So if let's say this was not there, then what we would have to do is, if we wanted to get something based on year, we will have to create a view like group by year and then do this thing. If we wanted something based on brand, again we will have to create another view where we will say group by brand and then calculate average transaction value. So instead of creating all those different views, now we have created it in a single consolidated metric view, and directly we can use them, and at the runtime it will be able to do that group by for us. So we don't need to create different copies of the views. In this central one metric view, everything is created for us. And if we want to edit anything here, we will click on this edit part. And here there are two ways to edit it. So one is like using UI, second one is using YAML. So if we go to, let's say, the measures part here, we can see this is the name of this particular measure. This is the expression. So it is doing count one, or somewhere it is doing sum, somewhere it is doing count of distinct. This is the comment. And then on the right side, we see the same details where we can make any changes. So instead of saying, let's say, unique customers, we can call it as number of customers so that it is more readable. And this is the display name, the name which is appearing here. So this also we will need to change it. So let's say we can call it as number of customers. And how these two are different is, in this case it is kept as same, but this is like it can be with underscore and the technical name, and this can be the real name which will be displayed in the dashboard or whenever user is querying that. And this is the comment which is coming here, and this is here we can add some synonyms also, so that apart from using this for dashboard or query, when we will use it for any AI related services like Genie, there it will know that if user is asking customer count, or if user is asking distinct customers, or user is asking number of customers, so everything is same. That is how these synonyms are very important. And here we can define a format as well. So this is a number, so that is why it says number. And formatting also, we get various options how we can control the formatting of each and every measure or dimension. So that is how we get very like detailed control what exactly we are going to do. Similarly, we can customize any of the dimensions through here. And if dimensions are straightforward because there are no aggregation involved, so these are most of the time these are simply just the column names from any of the table. That is how the dimensions are selected. And also we can edit it based on the YAML. So directly on the file we can go ahead and make the changes. We can change it here, or we can change it in the notebook where we had created. So this YAML section, it is common. So basically based on this YAML only, that part was created. And if we try to just understand it, so this joins, it is just joining the tables. Then if you notice, so based on this name, we have different dimensions defined. Like this is the name, this is the column being used, this is the display name, this is the comment, this is the format. So whatever options we were seeing in the UI, same options are available here, and that is how those were created when we ran it. So all these options were configured there, but that is how we can read it like item by item here also, and understand it, edit it if required. So with this, we can say that our metric view, it is ready to be used now. And I hope you got the idea, like what is the purpose of the semantic layer and purpose of this metric views. So now as we are done building our semantic layer, the next thing we are going to build is the consumption layer. And here we are going to use two main services, Databricks Dashboard and Genie Workspace. Also, we will use Databricks One, which is a like different UI to use these services only. So first, let's start by building a dashboard in Databricks. And to build the dashboard, we can build it manually, or here also again we can use a Genie code. So let's prepare the initial version using Genie code, then we can customize it based on our needs. So I'm going to copy the name of this metric view from here, and then I will ask Genie code to create a dashboard. Okay, create a detailed analysis dashboard based on the metric view this, and we will say like understand each dimension and measure, and then prepare the dashboard. So although it will understand automatically, but emphasizing on that is helpful. So let's provide this prompt and let's see what kind of dashboard it is able to prepare for us. So it has created one dashboard based on the details. Now it will open it automatically. I have selected always allow. If you are using for the first time, you may need to allow it also. So here I can see that it has automatically opened a new tab for the dashboard. And here we can see a blank dashboard has been created with this particular name. And currently there are no visualization which has been added here. And here it has thought of the visualization that it is going to build. These are the things it is planning to build there. So now after this is open, it is trying to build this, I think. And it seems to be taking too long, and it seems to be stuck also, I think. So let me try to stop it. Looks like this is not working. So we will give it like another try. So let's directly create a new chat here so that it will start from scratch. And now our dashboard is already here. So instead of saying like create a dashboard, we will say like update this dashboard. Then like based on the same thing. So first it is trying to understand the table structure, like the dimensions and measures which are there. And it has renamed the dashboard also with a good name. Now it is asking if it can add that metric view here. So I will like click always allow so that it don't ask it again and again if it has to do. Now it is starting the warehouse at the backend automatically. It is started now. And now we can see it is saying that the metric view it has added. So let's go to the data tab and let's check it out. So here we can see that it has added the metric view automatically. It is available now. If we go back to the page, now it is thinking what kind of visualizations it can create. So here we can see that it has started adding the visualizations automatically. So at the top, these seem to be like numeric visualization, like what is the total revenue, what is transaction count, and below it is adding some graphics. So that is what it is doing automatically currently. So it keep adding different things here, like revenue by customer type, sales channel, revenue by country. So it is adding like so many visualizations here. And now it is saying that it has created the dashboard. but we don't see any visualization. It is saying like select fields to visualize. So we can ask as a follow-up question that all visualizations are empty, no fields are selected. And now it is trying to fix the issue. It is running something. And now we can see that it has automatically updated all these widgets with proper data. So here we can see like what is the total revenue and what is the transaction count, how many customers we have, what is the average transaction value, and then we can see the revenue over time. We can see revenue by country. This one is revenue by brand. Then revenue by state and country. Oh, this one was category, sorry. So likewise, it has created these different visualizations, and we can edit them. So if we want to drag them around, we can do that. And if you want to customize any of this, if you want to, for example, change this one to any other visualization, we can do that. We can change the colors. So basically whatever customization we want to do, we can do over here. And if even if we want to add more visualization, we can add it from here and then select what exactly we are trying to do. And for each visualization also we can use this Genie here, so that if we tell it to like show me revenue by country, for example, it will add to this particular visualization. So at single visualization level also we can use Genie code. And this is the power of metric view, the one I was talking about. For example, here we are showing revenue by payment mode, here we are showing revenue by stage. So instead of creating two data sets, so if let's say we did not have this metric view, then what we would have to do is we would have to create a SQL here, and there we would write like a total revenue, and then stage, and then group by whatever we want to do. Let's say group by stage or group by that. So for each group by and what data we want to show, we would have to create different views or different SQL data sets here. But because we have this metric view, we don't need to create them separately here. And using this same, it is able to do that group by thing at the runtime, like in the dashboard directly. It is able to show us the data based on brand, based on category, based on payment method, basically based on whatever dimension we want to see any aggregated measure, we are able to showcase it here. So that is why this metric view, it is also getting very popular. And this semantic layer building using metric view, that is something, it is becoming more and more user friendly and easy to use and access. And we are also using it for multiple clients. Currently we are proposing to new clients and they are also really liking it a lot. And now we are ready with our dashboard. And if we want to share this dashboard with someone, so from here we can share like in Databricks only. And what I will do is I will export this file here and put it in the repo, so that if you don't want to create it using Genie, you can directly import the dashboard and then use it. And after creating any dashboard in Databricks, the next thing we need to do is publish. So I will click this publish, and then the dashboard will be published and it will be ready for any user who wants to use it. And here we we created it using Genie code because I wanted to showcase the capability. But before it was there, or in general also, we can create it of our own as well. So if we come to this dashboard section, so this is the dashboard we just created. And here we can create a dashboard from scratch, or we can import a file also here. So the file I have provided, you will be able to import that one. And if I click on create dashboard, then it will open a blank sheet here. Here also it is suggesting that we can build using Genie code. Same prompt we can specify here, or manually also we can go to the data, add the data set, the metric view, or the tables also we can use. So the first we can create the data sets, then we can add the visualization. So that way, manually also it is possible to create this dashboard. Now, as we are done with the dashboard, so now we are going to build another consumption service, which will be Genie Spaces. So for that, we will go to this Genie Spaces here. Then we need to go to this news here. And here we will need to select the tables, the views, the metric views, whatever we want to supply it. In our case, we will be supplying it with our gold layer tables, even though we can directly supply the metric view as well. But for this demo, we will be using gold layer table so that we can show its capabilities, it can generate the SQL queries, and it can show so much information dynamically. So we will go to our retail queue. Then we have our gold layer here. And in here, we are going to select all our tables and views which are there and click create. And that's it. With this, just by selecting these tables and views, our Genie space, it is created and it is ready to be used. And in this Genie UI, this is where we can supply our question in natural language. These are some of the questions it is suggesting from its own side. Then on the right side, these are some configurations. These we will go into, but first let's try out something. Let's say here, if we ask a question like which customer is doing max transactions, so that we know which customer is doing maximum number of transactions. So here we don't need to specify anything in SQL. We can ask it in the plain English. It is powered by AI, so it will be able to understand what we are trying to fetch. Then it will fetch the data. Then it will fetch the data, and it is able to tell us that this is the customer which is having the maximum number of transaction performed, and it is also saying like this is significantly higher than the second place customer. So this kind of analysis it is able to provide it directly. And if we want to understand how it was able to do this, so it has executed a SQL query, and this is the result of that SQL query. If we want to see the code, we can see the code also which it has generated. So just by asking this question, it knew automatically that it has to go into fact sales and dim customer table. It has to join based on this, group by based on this, and then use all this. So this query, it generated automatically, it executed the query, and then it provided us this result all in couple of seconds. So that is how powerful it is. If we have multiple tables, multiple users, they want different insights into the data. So now there is no need to create dashboard. Like dashboard are still helpful, but if they have some question of their own, then they can directly ask here in the Genie spaces. And if we look into these configurations now, so this is the description part generated via AI. I can accept it, I can edit it if required. This is just a description of this space. And then here are some common questions that it will suggest when it is being loaded for the first time. So those question list that we just saw there, so we can change that list from here, so that this list will appear when a user will log in, and some suggested set of questions we can set up here. And then if we go to the data section, so these are the tables we had supplied it, tables and views. And we can add more here if required. And if we go to the instructions part, so here we can set up some instructions as well, like keep this language professional, or if there are some short forms the user is using, we can specify here. Basically, if we want to provide any custom instruction to customize this output, we can provide those instructions here in plain English. And in the join section, we can define the joining between different tables. So for example, we know that fact sales, it is being joined with our customer table based on the customer ID column. So although it was able to figure out the join condition automatically when we asked it that question, But if we specify it here, then it doesn't have to search for that information. So in production ready Genie spaces, we always specify the joining condition, which is very important. And here in the SQL expressions, we can define some standard measures and dimensions like we defined in our metric view. So we can define some standard definitions here. Like if user is asking for total revenue, we can say it shall be sum of the revenue column. We can provide some synonym, we can provide some instructions. So like that, we can configure all these things here. And here we can provide some common SQL queries and functions. So if there are some frequently asked questions we want to answer directly, so we can mention the question here and the SQL query here so that it doesn't have to generate every time on its own. So whatever frequently asked SQL queries are there, we can add them here. And in the top section, this is where we can monitor the previous queries which has been asked here. And in benchmarking, we can set up different benchmarking also, like based on the question, what shall be the answer or what shall be the SQL query. So that way we can add these benchmarking and do the testing. So there are so many things we can do, especially with this Genie spaces. I have created a dedicated video on Genie spaces also. You can check out if you want to understand each and every option in detail. But for this project, this demo, I think this much is enough because now we can ask any natural language based questions directly from here. And recently, Databricks, they have introduced a new service also. So let's say if I'm an end user, right? I'm a business user. So I don't care about all these things in Databricks, like how the code is written, how like the catalog is organized. I don't care about anything. I simply care about my dashboard and this kind of Genie spaces where I can explore the data. That's it. So for those kind of users, recently Databricks, it has introduced a service named as Genie. Earlier it was called as Databricks 1. Now they have renamed it to Genie. So if I click this, it will take me to a separate UI in Databricks. And in this UI, it will look very different if you see, and it is very simplified. It doesn't have all those technical options. This is the home. These are some recommended things it is showing. And on the left side, we can see that here we can see all the dashboards which are there. If I click it, it will take me to the dashboard page. Similarly, if here I can see the Genie spaces which are created. And if I click it, it will take me to a new tab in the Genie space, the same space that we were using earlier. And here we can ask similar kind of questions. If I go back, here we can see the apps which are created in Databricks, some domains. This is a new concept they have, and a new chat. So all these options we are getting. So if we know directly where to look for that particular data, we can go there. And let's say if I want to know something and I don't even know whether that data I'm looking for, it is in a dashboard or Genie space, then those kind of questions also directly also we can ask here as well. So for example, if I simply say like how my revenue is changing over time, so I'm not telling it where to look for this data. So automatically it will check out like where is the revenue related data and then try to answer it. And it is seeing that it is checking in this dashboard whether this data is available. Then it is checking in this one. It is checking in this Genie space. It is trying to ask this question so that both side it will get the information, then combine it, then showcase to us. And here we can see that it first found the metric view, it also found the dashboard, it also found the Genie space. So we don't need to worry about where the source of the information is that. We can simply ask our question. It will do anything that is required for us and simply provide us insight into the data. And this is the answer it has come up with. So it is saying like revenue shows sharp decline in recent months. It is showing some analysis, visualization also it created automatically, and some key findings. It is trying to explain the data also to us. And if we want to know what is the source of this information, so here we can see that. So here it is using that Genie space. If I click it, it will show us. Here it used a query. So it ran the query. We can see the generated code as well, which query was run. So everything we can understand here. So this is how like this Genie, it is very powerful and it is very easy to use for business users because they don't they are not technical people. They don't want to run SQL queries and everything anything. And now they don't even need to find the dashboard Genie spaces or anything. Simply they can ask their question what they want to know. It will answer them. This is the like data that you are looking for. So that is how powerful this Genie has become now over the period of time. And now coming back to our architecture. So this part we have completed now, like ingestion, transformation, semantic layer, and consumption part also. Unity catalog we are using along the way. Whatever we are using, it is created in Unity catalog. And agentic AI based development also, we are using the Genie code wherever possible. Now we are left with one piece, which is orchestration. So we have these different pipelines that we created, but how do we run them end to end or on a daily basis? So that is where the Databricks jobs come into picture. So let's create a Databricks job for us. Now I'm back into my Databricks workspace. To create a job, again we will go to jobs and pipelines. And here so far we have used this ingestion pipeline, ETL pipeline. Now we are going to use the job, which says like orchestrating notebooks, pipelines, queries, and more. So this is how we will create a new job. Here we need to give it any name. So we can name it as like retail queue end-to-end job. And in this job, we are going to create multiple tasks. So first, we will start the ingestion pipeline. So that will be a pipeline that we had created. So I will click on this pipeline and the task name, it will be, let's say Postgres to bronze. And the type is pipeline. Here we need to select that pipeline which was there. And here by default, we don't see that pipeline because it is thinking we will do ETL. So if I remove this filter, then it will show the ingestion pipelines also. So this is the pipeline we had, ingestion pipeline we had created for Postgres to bronze. So that is what we will select here. And it is suggesting if we want to make any changes, we can do that in any of the step, but we don't want to make any changes. So I will close it. And now I will click on create task. So now our first task, it is ready. Now let's add the second task which was there. So this will also be a ingestion pipeline. This time we will use it from Salesforce. So it is asking us to create one, but we don't want to create one. We will select here. So Salesforce to bronze. This is our ingestion pipeline. I will close it. That is selected now. And I will click on create task. Oh, task name is required. So Salesforce to bronze. And here you will notice that this link is established automatically. And what it means is that this second job, it will complete after this first job is completed. And that is taken care from this depends on, and it is saying it will execute if the previous one is succeeded. So if I remove it, then both will start at the same time and execute parallelly. So in production workflows, because this is source to bronze layer, so we will want to run these parallelly. But in this Databricks free edition, there is a limitation that at any point in time, we can run only one ingestion pipeline. And due to this limitation, we will be executing them in a serial manner. So, so now our two tasks are ready. Third source for us, it is the ingestion from Blob Storage. And if you still remember, so there we have created a notebook that was not a directly ingestion pipeline. So this time we will use a notebook task, and this one will be blob to branch, and this is where we need to select the notebook that we want to run. So I have the notebook in this particular folder here, and this was the notebook blob to branch. So that one I select here. So whenever this task will run, it will run that notebook. Now we are done with the source to branch part. The next thing we need to do is silver layer. And for silver layer, it was a pipeline we had created, silver and gold both. It was a common pipeline. So we will select ETL pipeline here, and we will give it a name like silver and gold, so that we know both layers it will be refreshing. Here we need to select that. So the pipeline name, it was retail transformations v2, and then I will create on uh, save this task. And here we can see that by default this picked up the silver and gold this way, but this one we want to run after the blob to branch. So I will select it again, and in the dependency, instead of saying the depending on that one, I will say it shall depend on blob to branch, so that it complete after all the three are done. So with this, now we are good. And after the data is loaded into bronze layer, the next thing we need is refresh the dashboard, because the dashboard will not be refreshed automatically. So for that also we need to create a task. And here I will click select dashboard, and we can say like dashboard refresh. Here we need to select the dashboard. So this is the name of the dashboard. And then I will click on save task. So now our job, it is ready end to end. So whenever we will trigger the job, let me trigger now while I'm explaining. So what it will do is, first it will ingest the data from Postgres to branch, then a Salesforce data it will ingest, then blob data it will ingest, then it will load the data for silver and gold tables. And in gold layer, we had created some of the things as views. So views, we don't need to refresh any data. And after that, we need to refresh the dashboard so that the latest data is used. And we had also created metric view. So that is also a view. So we don't need to refresh any data. The data is fetched at the runtime. And same goes for Genie space. So in Genie space also, the underlying data sets are fetched whenever we ask any question. So there also, we don't need to refresh anything. It will automatically pick up the latest data which is available. And now if we go to the runs section, so this is where it will run all these things step by step. Currently it is running the first job, which is Postgres to branch. And while it is running, let's check out some other options as well. For each of the task, which whatever is there, we get different options here, like compute. Although we are using serverless, we can change here if required and supported. And then this is an important section, which is retries. So currently, if anything fails, it will try total 4 times. We can change it if we want to increase it or if we do not want to retry. But by default, it will try out the things 4 times if anything fails. And on the right side here, we can add a description to the job. We can add a schedule and trigger as well. So that currently we are running it manually, but if we want to add any schedule, so we can do it from here. We can even trigger it based on any file arrival, based on any table update, or run in continuous mode, like one run after the other. But scheduled one, it is the most commonly used. And let's say if we want to run it every 1 day, and if we want to specify the time also, we can specify like every day it shall run at this particular time. And if we want to schedule it based on anything advanced, like execute on any every third Wednesday of the month at this time or something, then we can use this cron syntax. So this is a syntax we can generate online or using any LLM based on our need. So this provide very granular control how we can add the triggers. And if I scroll below here, we can add some job parameters if we want to pass something dynamically. In our case, it was not required. And here we can specify the job notifications as well. Like if we want to, let's say, get any email. So here, if I specify any email address, so now to this email address, it will automatically send an email in case of failure, success, duration warning, starting, or if in case of streaming job, there is backlog as well. So this kind of notification we can set up so that whenever if the job is successful or if it is failed, we get the automatically generated email notification as well. And here we can integrate Git if we want to manage the uh, different versions of this job and the code that we are using. Now let's go back to our runs and let's see if it is completed. Looks like it is completed now. And if we want to check at any step what is going on, so we can click that step. It will take us to that particular ingestion pipeline or notebook or the ETL pipeline, and then it will showcase the similar execution parameters which are available. So with this, the execution, it is completed successfully now. And in this same pipeline, if we are getting new data in the source, so automatically it will ingest that new data from end to end. And this, it completes the demo part of the project. I hope you got really good idea now how we can set up different sources like Salesforce, Postgres, Blob, and then how we can ingest the data from them. We also understood like ingesting the data, it is directly available through UI now. It is very easy to use. And the transformation part also, we can do easily using the ETL or the Lakeflow Spark declarative pipelines. There we just need to provide some basic syntax and everything works for us. Incremental data is taken care automatically. Quality checks we can apply on the fly. So in this demo, what we understood is how to set up the real sources like Postgres, Salesforce, and Blob Storage. How we can use Lakeflow Connect to ingest the data without writing any code. How we can use autoloader to ingest incremental data based on files. We saw how we can build the silver and gold layer using Lakeflow Spark declarative pipeline. There also the incremental load is taken care automatically. We can specify data quality checks on the fly. Then we built a semantic layer where we defined our dimensions and measures. Then we created a nice dashboard, a Genie space to ask any question in the natural language. We also saw the Genie or Databricks One UI, which is intended for the business users. And we also orchestrated everything end to end using a Databricks job. And during this entire process, we used Databricks Genie code also a lot so that we understand how we can do the development easily to save our time. And this is how going forward, every data engineer, they will be building these pipelines using these AI tools. And if you appreciate the effort I have put in here, please put a like and comment on this video. And also share this project with others so they can also learn this latest stuff that you just learned. So that's all for now. See you in the next video. You can subscribe if you want to stay in touch. So bye bye. Happy learning.